Hello and welcome to our other series of mathematics lesson. We have been looking at this topic, algebraic expressions, equations, and inequalities. In our last lesson, we discussed so much about inequalities, where we said they are expressions which normally use the inequality symbols, namely greater than, less than, greater than or equal to, and less than or equal to. A good example of an inequality is when you are given 2x is less than 4. We also looked at how we can be able to solve these inequalities. Today, we want to look at another subtopic, that is linear simultaneous equations. Now, it is important to note that whenever we talk about linear simultaneous equations, these are simply equation or two equations that have got a singular solution for the both values of x and y. If you are given a linear equation of the form a quarter x is equals to 8, for instance, this kind of an equation only has one unknown. That kind of unknown is the x. We can be able to solve this and obtain the value or the solution to x. And if we're able to solve this, then this one will give us that x is equals to 8 multiplied by 4, which will be 32. This 32 is a unique solution, and this particular equation has got a single unique solution, which is 32. But in case we have two unknowns in an equation, so that we have 2x plus 3y is equals to 8, for instance, then you'll discover that there are going to be several solutions which are going to end up giving us the same answer, which is 8. What if we add another equation? Let's say a half x plus 3y is equals to 9. Then we can be able to combine the two and have a single solution that will be representing the two equations that we have here. When we get that particular answer, or that unique or that single answer that satisfies both these equations, then we'll refer to that or these kinds of equations as being simultaneous, because they have the same answer or the same solution. So you can be able to say that simultaneous equations are equations that have a single solution that satisfies the two linear equations. The main aim of this topic today is for us to be able to know how we can be able to solve simultaneous linear equations. There are several ways of solving simultaneous linear equations, but in this particular topic, we are only going to consider two particular methods of solving linear simultaneous equations. And these two methods which you're going to look at is by use of what we call substitution method, and then two, we'll look at another method called elimination method. These are the only two methods that you are going to consider in this particular topic, although we have other methods of solving simultaneous linear equations, such as the use of graph or the graphical method, we can also use matrices for us to be able to solve this. So we're going to consider substitution in our first case. Now, there are normally steps or 3 steps followed whenever we want to solve linear equation by use of substitution. The first step, or step number 1, is we substitute one of the equation in the other. Substitute one of the equation in the other. 2, after substituting, you will get the solution of the first pronumeral. Then step number 2, solve the remaining pronumeral. And we recall, we say that pronumeral are the alphabetical letters which are unknown in that particular equation. Then the final step, number 3, substitute. Substitute to find the value of the second pronumeral. So we say that these linear or simultaneous linear equations are going to have or consist of 2 unknowns. So in solving them, we need to first get the first unknown, then we substitute for us to find the value of the second pronumeral. We're going to consider a number of examples on how we can be able to use substitution to solve simultaneous linear equations. Example 1. Solve each of the following. Pairs of simultaneous equations by using substitution. Now it's very important for you to note the kind of method you have been asked to use, because every question will consist or will direct you on which method you're going to use to solve a particular pair of simultaneous equations. But A, x plus y is equals to 10. Also, y is equals to 4x. Now, if you look at this particular pair of simultaneous equations, we have the first equation consisting of the 2 pronumeral. Then the same is also satisfying this other equation of y is equivalent to 4x. We can be able to note that this is equation 1 and this one is equation 2. Equation 2 has been simplified to give us the value of y in terms of x, that is y is 4x. And therefore, the first step in solving simultaneous equations by use of substitution has been solved by them giving us this second equation in terms of y, in terms of the other pronumeral, which is x. Therefore, we're going to go directly to the second step of now making the replacement. Where there was y in the first equation, we replace with the value of y, which you have found it to be 4x in the second equation. So replace equation 2 in the first equation. This will give us x plus. Now the value of y from equation 2 we have been told is 4x. So instead of writing again y, we write that y in terms of x, which will be 4x is equals to 10. We can call this equation 3. We now proceed in solving this equation 3 because we now have one pronumeral. That is, equation 3 is in terms or only has one unknown, which is x. And therefore, if we can be able to solve and get the value of x, we can replace that value in this equation, in the second equation, for us to find the value of y. Now, x plus 4x, x and 4x are like terms. Therefore, we can be able to add them. 4x plus x, you'll get 5x. Is equals to 10, which is on the right hand side. Now, for us to be able to get the value of x, we divide both sides by the coefficient of x, which is 5. When we divide both sides by 5, it will give us the value of x to be 2. Now that tells us that 2, or the value of x as 2, is a solution that satisfies the two equations, either equation 1 and also equation 2. After getting the first pronumeral, we need to go ahead and get the second pronumeral. And in getting the second pronumeral, we said we substitute now the value of x, which we have found in either of the two equations. You can either substitute the value of x in the first equation or the second equation for you to get the value of y. Let us substitute it in the second equation because it is easier, where you are told that the value of y is 4x. And you have been told, or we have found out, that the value of x is 2. So we make that particular substitution. This will be y is equals to 4 multiplied by 2. Therefore, y is going to be 8. Now we can be able to say that the value of x is 2, the value of y is 8. And this particular solution can be able to solve, or is a solution that matches the two equations. You can always go back and check whether 2 and 8 are the required solution for these two particular equations. But that's how we can be able to use substitution to solve linear simultaneous equations. Example B, 4x minus y is equals to 6. Then y is equals to 2x minus 4. So again, these are simultaneous linear equations. We can be able to take that as equation 1 and this other as equation 2. This first step has been done for us, that is getting one of the pronumeral in terms of the other, and this is equation 2. In equation 2, y has been written in terms of x, and that the value of y in terms of x is 2x minus 4. We therefore need to go ahead and replace where there is y in the first equation, we replace it with 2x minus 4. So replacing value of y in equation 2 to equation 1, we'll have 4x minus y. Y is now 2x minus 4. 2x minus 4 is equals to 6. This gives us the third equation. If we expand this, then we'll get that 4x, when you open this will be minus 2x. Because of this minus and this minus, you're going to have a positive. So plus 4 is equals to 6. 4x and 2x are like terms. 4 and 6 are like terms. Therefore, can be able to put them together and solve them. When we take 4 to the other side, it will change the sign to be negative. And on the left hand side, we are going to remain with 4x minus 2x, which will give us 2x is equals to. Now this will be 6, subtract 4, leaving us with 2. And therefore this will tell us that the equation or the value of x is going to be 1. That is when you divide both sides by the value by the coefficient of x, which is 2. After getting the value of the first polynomial x, we need to substitute in the second equation for us to obtain the value of y. Substituting value of x in the second equation for us to get the value of y, you are told that y is equals to 2x minus 4. So this will be 2 multiplied by the value of x, which you have said is 1, then subtract 4. When we solve that, you'll get that the value of y will be equal to 2 multiplied by 1 is 2, 2 less 4 is negative 2. Therefore, the solution that can be able to solve these two linear equations is that the value of x is 1 and the value of y is negative 2. That is, x is equals to 1, y is equals to negative 2. C, 3x plus 2y equals 19, then y equals 2x minus 8. Again, this is a pair of simultaneous equation. This one, we can take it to be the first equation, and this one to be the second equation. Again, the first step has been done for us, that is getting one pronumeral in terms of the other, and we've been given that y is equals to 2x minus 8. Therefore, we can be able to proceed and replace the value of y in the first equation for us to obtain a third equation. So when you replace the value of y in this equation, you will find 3x plus 2. Instead of y, we have said we put the value of y, which is 2x, which is 2x minus 8. We have been told all that equals to 19. Therefore, this is our third equation. If we expand this equation or this particular bracket, we're going to have 3x plus 2 multiplied by 2x, we're going to get 4x, subtract, because plus and minus will give us a subtraction. So 2 multiplied by 8 is 16, which is equals to 19. Again, you will discover that these are like terms, while negative 16 and 19 again are like terms, and we can be able to group those like terms before we solve them. Now 3x and 4x, this one will give us 7x is equals to 19. We take 16 to the other side, it will change the sign to be positive, so we shall have positive 16. This will give us 7x is equals to, when you take 19, you add it to 26, you will get 35. And therefore, you can be able to proceed and solve to get the value of x by dividing both sides by 7. So 7x is equals to 35. We divide both sides by 7 to get the value of x. This will give us that x is going to be 5. Now, after getting the value of the first pronumeral, which is x as 5, we can be able to proceed and get the value, obtain the value of the second pronumeral, which was y. And therefore, we need to substitute the value of x in the second equation. When you substitute in the second equation, we're going to get that y was equals to 2x less 8. So this will be y is equals to 2. The value of x, we have found it to be 5 minus 8. This will give us that y is equals to 2 multiplied by 5 is 10. 10 minus 8 is 2. Therefore, y is equals to 2. So you discover that you'll have found a solution that satisfies the two equations. That is, the value of x is 5 and the value of y is 2. So before we go ahead and look at several other examples on substitution, let us look at the other method of solving simultaneous linear equations, that is the elimination method. Now again, this is another method of solving simultaneous linear equations. The term elimination normally involves either adding or subtracting for you to eliminate a particular polynomial in a term or in an expression or in an equation before you go ahead and solve it. So we are saying that elimination involves addition or subtraction of the two equations for you to be able to remove or eliminate, eliminate or kill or completely remove one unknown, which in this case we are referring to it as the pronumeral. We are saying that we can be able to use addition or subtraction when we want to kill or eliminate one of the pronumeral. We are going to look at instances where we add one equation to the other or subtract one equation from the other for us to obtain or to eliminate one of the pronumeral. We are going to look at such instances or such cases. Now, in case you are given an equation of this form, 3x minus y is equals to 4, and 5x plus y is equals to 4. And we are supposed to eliminate one of the pronumeral. Then it follows that you need to inspect which pronumeral is easier to eliminate or to deal with. And in experience, it is always good or it is always easier to eliminate pronumeral with the same coefficients in both equations. Now, if this is equation 1, and this is 2, consider the coefficients of the two pronumeral in the first and second equation. Like in the first case, or the first pronumeral x, the first equation has a coefficient of 3, the other one has a coefficient of 5, so they are not the same. And if you consider this, the second pronumeral, that is y, the coefficient of y in the first and second equation is 1. And therefore, it is much easier to eliminate this particular pronumeral y because it has the same coefficient in both the two equations. Now, when do we use addition and when do we use subtraction when you want to eliminate a pronumeral? We consider the signs before that particular coefficient. Like in this case, we have -1 and we have +1. How can we be able to eliminate this and ensure that this particular part gives us the value of y to be 0, -1, and +1? Then you'll discover that for you to eliminate the value of y, you need to add the two equations. So that a -1 plus 1 will give us a 0. What if you had subtracted? It will give you -1 minus 1, which will have been -2. And therefore, you not have eliminated that particular pronumeral. So we are saying we are going to add the two equations so that we get or we eliminate that part. Now 3x plus 5x, you will get 8x. We have said that -y plus y will give us a 0, or 0y is equals to 4 plus 4 is definitely 8, and 0y is simply 0. So this will be 8x is equals to 8. You'll discover that we have eliminated one of the pronumeral and we are left with one of the pronumeral. So you can now go on and get the value of x. After getting the value of x, you can replace or substitute in either of the two equations to find the value of y. What if this was the case? We have 2x plus 3y is equals to 6, and 2x minus 5y is equals to 7. Now if you look at these two pairs of simultaneous equations, we have two pronumerals in both equations. We have x and y in both the two equations. And when we want to eliminate, we have said you check and you ensure it is easier to eliminate the one pronumeral which has the same coefficient in both the two equations. And if you look at this, the coefficient of x is 2, the coefficient of x is 2 in the second equation. What about the coefficient of y? It is 3 in the first equation, -5 in the second equation. So which one is easy to eliminate? We said for you to be able to easily eliminate the one with the same coefficient. So it is easy for us to eliminate x. Now, do we add or subtract for us to eliminate this part? If we add, we'll get positive 4x, and therefore we'll not have eliminated it. Therefore, it means we have to subtract the two equations for us to obtain a 0 or to eliminate the value of x. So we're going to subtract, and when you subtract 2x minus 2x will get 0, plus 3x minus 5, no, plus 3y minus 5y, you'll get minus 2y is equals to, when you subtract 7 from 6, you'll get -1. And therefore, we're going to have 2y is equals to 1 as our third equation. So you'll discover that in this third equation, we have already eliminated one of the pronumeral. Now, there are certain cases where you do not have to add direct or subtract direct. There are some things that you must do. One, you must ensure if all of them, if you do not have the same coefficient in the two pronumerals in the two equations, then there are some procedures that need to be followed. And that is, the procedures are mainly there for us to be able to have the same number of, or the same coefficient in both the two equations. Let us consider such a case. 3x minus 2y is equals to 1, then 2x plus y is equals to 3. Now if you look at this pair of simultaneous equations, the coefficients of x and y are not the same. Here the coefficient of x is 3, the coefficient of x is 2. The coefficient of y is -2, the coefficient of y is +1. and therefore you cannot go ahead and either subtract or add directly. There are some procedures that we are going to must perform on this pair for us to have one part being eliminated. So it depends. If you want to eliminate the part with x as a pronumeral, then we need to ensure that the coefficient of x in the two equations are the same. And how can we ensure that? We can multiply, or what we do, we multiply the first equation with the coefficient of x in the second equation. That means we multiply the first equation with what? The coefficient of x in the second equation, which is 2. Then the arrow pointing down indicates what you must multiply the second equation with. So the second equation is multiplied with the coefficient of x in the first equation. So this one we multiplied by 3. So you see we have reversed. We have multiplied this one by the first equation by 2, the second equation by 3. So in that case, this one will give us 6x minus 2 times 4 times 2 is 4y is equals to 2. 3 multiplied by 2 is 6x plus 3 multiplied by y is 3y is equals to 3 multiplied by 3 is 9. So we find that we now have one part which we can easily be able to eliminate. And for us to eliminate this, we simply subtract the second equation from the first equation. What if you wanted to eliminate the other part, or the part of with y? Using the same 3x minus 2y, 2x plus y, this one is equals to 1, is equals to 3. So if you wanted to eliminate the part with, or the pronumeral y, then again we need to reverse the coefficients of the two, the values of y in the two equations, and multiply our equations with. In this case, if you want this one to be the same as this, then we must multiply this positive 1. We multiply the first equation with the coefficient of y in the second equation, which is positive 1. Then we multiply equation 2 with the coefficient of y in the first equation, which is negative 2. When you do that, we are multiplying. So 1 times 3x will have 3x minus 2y is equals to 1. When you multiply both sides by negative, all through by negative 2, you'll get negative 4x minus 2 times positive 1y, you'll get minus 2y is equals to minus 6. So you'll discover again that you have ensured that the coefficient of y is 2 or is common, and therefore you can go ahead and eliminate. And for you to be able to eliminate that, then we need to subtract. You subtract the second equation from the first equation so that this part is eliminated. Examples: solve each of the following simultaneous equations by using elimination. So we said that the method will be stated for you. Whether to use substitution or elimination is not up to you. It is the examiner who will determine which method you are going to use. Like in this case, we have been strictly restricted to use of elimination method. But we are told that x minus 2y is equals to 1 minus x plus 5y is equals to 2. Now these are two pairs of, a pair of simultaneous linear equations. We are going to use elimination, and we say that before you choose which part to eliminate, always cross-check and check if we have pronumerals with the same coefficient. like I can be able to see that the coefficient of x is 1 in both equations, and therefore it is much easier to eliminate the x pronumeral as it will be to eliminate the y pronumeral. And for me to be able to eliminate x in this particular pair of simultaneous equations, then I need to add the two equations, so that when I add the two equations, I'll be able to eliminate this particular part. X minus x or plus minus x will give us 0x, so this part will go to 0, and therefore I will have eliminated the value of x. Then minus 2y plus 5y, this will give me plus 3y, is equals to, when I add the other part or the right hand side, 1 plus 2, I will be able to get 3. Therefore, this tells me that 3y is equals to 3 is our third equation, and we can be able to solve it for us to get the value of y by dividing through by 3. Therefore, the value of y, you'll be able to discover that it is 1. After getting the value of one of the pronumeral, we go back and substitute in the equation for us to get the value of the other pronumeral. And you are not restricted to either the first or the second equation. It is up to you to choose which are you going to use. Will you use the first equation or the second equation? But always choose the one that is simpler to use. So like in this case, we want to use this first equation to get the value of x. You are told that x minus 2y is equals to 1 in the first equation, but we have found out that the value of y is 1. Therefore, we substitute the value of y in that equation to get the value of x. So this will be x minus 2 multiplied by the value of y, which is 1, is equals to 1. So this will be x minus 2 multiplied by 1 is 2, is equals to 1. We take 2 to the other side, that means we add it on both sides. So on the left hand side, we shall have x is equals to 1 plus 2. That will give us that x is 3. And therefore, can be able to say that the value of x is equals to 3, the value of y is equals to 1. And this equation solution is satisfying both the two equations. Example B, 3x minus 2y is equals to 5. 5x minus 2y is equals to 11. Again, this is a pair of simultaneous equations. We want to use elimination method for us to be able to solve that. Now we have 3x minus 2y is equals to 5. That is our equation 1. 5x minus 2y is equals to 11. This is our equation 2. Now again, we said for elimination we choose a pronumeral which has got the same coefficient. Like in this case, 3 and 5 are not the same, so we choose to eliminate the value of the y pronumeral because they have got the same coefficient, minus 2, minus 2. And how can we be able to eliminate that? Where we have minus, we have minus. So when the signs are the same, then we subtract. So we're going to subtract the two equations, or equation 2 from equation 1. And when you subtract, you'll get 3x minus 5x to be minus 2x. When you subtract minus 2 minus minus 2, that will be minus 2 plus 2, which is 0. So plus 0 is equals to, when you subtract the right hand side, 5 minus 11, you are going to get negative 6. And therefore, the third equation is negative 2x is equals to negative 6. We can be able to solve this third equation for us to obtain the value of x, and that is by dividing both sides by the coefficient of x, which is negative 2. That is negative 2x is equals to negative 6. We divide both sides by -2. So this will give us that x is equals to 3. And therefore the value of x is 3. You can now go back in either the second or the first equation and substitute it for you to get the value of y. And I've told you, you can use either the either of the two linear equations because they are not limited to one. In the first example, we used the first equation. Let us use the second equation in finding the value of y. Our second equation is 5x minus 2y is equals to 11. But we have found out that x is equals to 3. So when you make that substitution, that will be 5 multiplied by 3 minus 2y is equals to 11. 5 multiplied by 3 is 15. So 15 minus 2y is equals to 11. When we group the like terms together, we'll remain with -2y on the left hand side is equals to 11 subtract 15. So this will be minus 2y is equals to 11 subtract 15, you'll get -4. And therefore, for you to get the value of y, you divide both sides by -2. Hence, y, or the value of y, will be +2. So the value of x that satisfies the two equations is 3. The value of x that satisfies the two equations is 3. And the value of y that satisfies the two equations is 2. You can always go back and substitute and see if they are going to give you the same answer. Like, if we decide to test using the first equation and see if actually it is true that the value of x is 3 and the value of y is 2, we simply go to the equation. So where there is x, we replace with 3. So 3 by 3, this will be 9 minus. The value of y we have said is 2. So 2 multiplied by 2 is 4. When you do that, you will get 5, which is the same. Now the same also can be able to solve the second equation. Where there is x, we replace with 3. So this will be 5 times 3, which will be 15. Subtract 2 multiplied by the value of y, which is 2, you'll get 4. The answer is 11. So you see, 3 and 2 are pair or are solutions which are satisfying the two equations. 5x plus 2y -x, now this is simply x, plus 7y. The first equation is equivalent to -7, and this other one is equivalent to 25. Now again, these are a pair of simultaneous equations, but if you check through, you'll not find either of the two pronumerals consisting or containing the same coefficients. The coefficient of x is 5, it's 1, so they're not the same. Coefficient of y is 2, it is 7, therefore it is not the same. This calls us to apply some procedures in making either x or the coefficient of x or y to be the same. So this example, let us make the coefficient of x to be the same. We have 5x plus 2y is equals to -7, x plus 7y is equals to 25. We said for us to make the coefficient of x to be the same, we need to multiply the first equation with the coefficient of x in the second equation. Therefore, we multiply the first equation by the coefficient of x in the second equation, which is 1. Then the second equation, we multiply with the coefficient of x in the first equation. The coefficient of x in the first equation is 5. Therefore, we multiply the second equation with 5. When you do that, you'll get 5x plus 2y is equals to -7. And when you multiply the second equation by 5, you'll get 5x plus 35y is equals to 5 multiplied by 25, you'll get 125. Which now has the same coefficient, and therefore can now move ahead and eliminate x in that particular process. So we have 5x plus 2y is equals to negative 7. We have 5x plus 35y is equals to 125. Now, how do we eliminate 5? So they are having the same sign, that is positive sign. Therefore, we're going to subtract the two equations, or we're going to subtract the second equation from the first. This will give us 0 plus 2 subtract 35, you will get minus 33. You'll get minus 33. Y is equals to, when you take minus 7, you subtract 125, you'll get minus 132. This will be negative 33y is equals to negative 132. We have eliminated the x as a pronumeral. We can therefore proceed in getting the value of y by dividing both sides by the coefficient of y, which is negative 33. So this will be negative 132 all over negative 33, which will give us the value of y as positive 4. After getting the value of y, we need to get the value of x by substituting the value of y in either of the two equations. Let us substitute it in the second equation, where we are told that x plus 7y is equals to 25. But y, we have been told, is 4. We have found out y to be 4. So when you substitute, you'll get x plus 7 multiplied by 4 is equals to 25. This will give us x plus 28 is equals to 25. We take 28 to the other side, it will be minus. So that means that the value of x will be equal to 25 less 28, and therefore the value of x is going to be minus 3. Therefore, y is equals to 4 and x is equals to 3 are solutions that satisfies the two equations. X is equals to negative 3, y is equals to positive 4. That is example D. 4x plus 3y is equals to 18. 3x minus 2y is equals to 5. Again, this is a pair of linear simultaneous equations. We want to solve it by use of elimination. In example 3, we eliminated x as the pronumeral. This time around, we want to eliminate the y as a pronumeral. Again, we'll discover that the value of y, or the coefficients of y, are not the same. And therefore, to make them the same, we are going to cross multiply with the opposite coefficient of the other. Like in this part, the first equation will multiply with negative 2, and this second equation will multiply it with the coefficient of y in the first equation, which is 3. So we're going to have 4x plus 3y is equals to 18. 3x minus 2y is equals to 5. We have said you multiply. Because we want to eliminate this part, we multiply the first equation with the coefficient of y in the second equation, which is negative 2. And we multiply the second equation with the coefficient of y in the first equation, which is 3. When you do that, negative 2 multiplied by 4, you'll get negative 8x. Negative 2 multiplied by 3y, you'll get negative 6y is equals to 18 multiplied by negative 2, you'll get negative 36. 3 multiplied by 3, you'll get 9x. 3 multiplied by 2y, you'll get negative 6y. 3 multiplied by 5, you'll get 15. Now if you consider these two new pairs of equations, now this being equation 3 and equation 4, the coefficient of y is now the same, and therefore we can now go ahead and eliminate. Again, you discover that the sign, this is -6, this is -6. Because the signs are the same, we are going to subtract for us to totally eliminate. So when you subtract 9 from 8, you'll get -17x. This one will give us a 0 is equals to minus 36, subtract 15, here you'll get 11, that is minus 51, that is -17x is equals to 51, and therefore we can be able to get, this is minus 51, and therefore we can be able to get the value of x by dividing both sides by -17. So this will give us x to be 3. What about the value of y? After getting the value of x, we substitute that value of x in either of the two equations to get the value of y. So when you let us substitute in the first equation, which was 4x plus 3y is equals to 18. But x is equals to 3. So this will be 4 multiplied by 3 plus 3y is equals to 18. This will give us 12 plus 3y is equals to 18. When you collect the like terms, that means we take 12 to the other side, it will change the sign. Therefore, it will remain with 3y on the left-hand side. 18 subtract 12, you will get 6. Therefore, the value of y, we divide both sides by 3, which will give us 2. Therefore, we can be able to say that the answers or the solutions to these particular simultaneous equations is x is equals to 3 and y is equals to 2. And those particular solutions can be able to satisfy these two particular equations. Now this brings us to the end of our discussion. We have looked on how to solve linear equations by use of two methods, that is the elimination method and substitution method. We have said the most important thing, always consider the equation, which method does the equation requires you to use. In our next lesson, we are going to see how we can be able to use these two particular methods in solving different problems in mathematics. Thank you.